Hello, can you hear?
Hello, hello, how are you?
Yes. Okay. So we saw the last is the unit circle. We can have if m is any rational number, we can have the coordinate right like this. We can obtain the slope if I draw a line from -1 0 with that rational slope. I can actually find the coordinates right. This thing we learned.
Yeah.
Right. So the thing is, how is this formula related to Pythagorean triplet? So that is the main idea. Why are we studying it here? So that is given in the next part. So since m is a rational number, so m we can write it as some u divided by v, right?
Mm-hmm.
Okay. In the book they are using v divided by u. Okay, that is fine. Then our coordinate is like this: 1 minus m square, 1 plus m square, and 2m divided by 1 plus m square. So if I replace v by u, then what will happen? Yes, simplify. Can you simplify?
The simplification.
Yes, just yes. So if you want to simplify, then we have u square minus v square divided by u square plus v square, right?
I see. Okay.
And this is 2uv divided by u square plus v square, right?
Mm-hmm.
Right. So so clearly, so this gives us the uh, Pythagorean triplet, right? So the Pythagorean triplet is corresponding. So 2uv, that is even, so that has to be b. So u square minus v square, 2uv and u square plus v square. So this is the Pythagorean triplet that I obtained right from the.
Wait. So because you're saying m is a rational number.
Right.
Okay. So from there. But how come u square minus v square is equal to a?
U square, no, that no. The thing is, we know that the b is always a even number, right? So b has to be
Yeah.
this one, right?
Uh-huh.
Because two uv is the even number. So once this is fixed, then this has to be a, right? Because a square plus b square is equals to c square. So this is the bigger quantity, right?
Mm-hmm.
U square plus v square.
Okay.
Right. So this one you can also verify that whether it is true or not. So u square minus v square whole square if you do plus
Mm-hmm.
2uv whole square. So then it is and plus v power 4 plus 4 u square v square, right?
Mm-hmm.
Plus v power 4. This is nothing but the u square plus v square whole square. So it matches, right?
Yeah, I mean, I can see that it matches.
Yes. Yes. So the idea is always we choose the b to be the even number. So I choose b to be this quantity.
So u square minus v square could be a, b, or c.
Yes. The thing is, I have to figure out what is a, b, and c, right, from this expression. So from this expression, I have to figure out what is a, b, and c, right? So the thing is, what we observed yesterday. 1 minute. Yes. So starting with any Pythagorean triplet, so a, b, c. So if I divide the equation by c square, I get a solution to the unit circle, right? I
Yes,
get
and
a
that at the same time is a Pythagorean triplet.
right. So this gives us so this a by c and b by c. So this is a solution to the unit circle, right? So that is the fact we are using. So I know that this is a solution to the unit circle. So the denominator has to be c, right? By definition, how I define.
Right, yes. So,
So the
yeah,
denominator has to be c.
yeah, so those four members, either each of those would be A or B or C.
Right.
But we just need to find out which one. Okay.
Right.
And that's in order to express in U and B.
Right.
But why do you want to express it in U and B?
No. The idea is so we got a so the thing was what was the starting point? The starting point was this is my unit circle. So from this point -1, 0, I am drawing a line that has a slope m. That has slope m where m is a rational number. So that is the that was the line. So line L is going through -1, 0 and having slope m, and m is any rational number. So I wanted to find what is this point, what is the coordinate of the point, right? So that we found out to be this thing, this expression. Now the idea is from this expression, can we get back a Pythagorean triplet? So that is the idea. So it is saying that for every rational point, if I will get a Pythagorean triplet from the unit circle.
For any rational number.
Yes, for any rational number m. So this then if I draw a line with slope m, then I'll get a point, right? And from this point, I will get a Pythagorean triplet. So what does it say? It says that any rational number, I will obtain a Pythagorean triplet on the unit circle.
Okay. Okay.
Okay.
Yeah.
Right. So this is fine, right? Now.
Yeah, but I mean the reason why you express it in B and U is because you want to represent a rational number.
Yes. So I
But
actually
B
want
and
to
U
obtain the Pythagorean triplet from this thing.
Okay, so first, so X and Y is only a point on the circle.
Right.
And a point in the circle where the line crosses, right? Yeah, that depends on M.
M. It depends upon M. Right.
So from there, you want to go back again to the Pythagorean triplet.
Right. Because our aim is to find that only, right? So our aim is to prove that for every rational point, rational number m, I can obtain a Pythagorean triplet. So that is some sort of one-to-one correspondence.
Okay, so from M, you just create a rational number, which is B divided by U. Then you replace, and then from there, you somehow figure out A and B are C of the Pythagorean
Right.
triplet. Yeah, okay. Understand.
Okay.
Yeah. Yes.
Okay. So let us try the exercise problems. So the first one says that so we have just seen that every Pythagorean triplet, so this is A, B, and C with B even. So have a formula like this, that A, B, C, you can write it as u square minus v square 2uv and u square plus v square.
So
Right.
in this case, there are no restrictions for U and B, because before we had, like, when we have S and D,
Yes,
S
yes.
must be
Because
greater than D.
because that was primitive Pythagorean triplet, so that's why the restriction were there.
I see.
So here is the usual Pythagorean triplet. So here we are not considering the primitive one. So where u and v can be different integers. So u and v are integers, so there is no restriction.
And also in this circle, because these A and B and C are along the circle, right?
No. So circle has only 2 coordinates, right? You don't have 3 coordinates. For a circle only we have 2 coordinates, right? One is the x direction, one is y direction. So 3 coordinates does not exist, right, in a circle.
Yeah, but I mean there are 2 coordinates because X and Y is divided, so because A and B is divided already by C, so that's why you
Yes,
have
yes,
only 2
that is
coordinates.
yes. On the unit circle, I will have a by c and b by c. This is the point on the unit circle.
And so this means that this circle will have all the Pythagorean triplets, no matter the value of the Pythagorean
Yes,
triplet.
that is the thing that is they are saying. For any rational number m, I will obtain, because there are infinitely many points on the unit circle, right? Because it is a continuous thing, right?
Right.
Yes, so that is the idea.
Okay. Fine.
So for example, here, so if I take u comma v to be 2 and 1 respectively, so this thing, then I get ABC as 3, 4, 5. So this is our smallest Pythagorean triplet, right?
Yes.
Right. So this is the starting. Then part A, they are asking. So if u and v have a common factor, so that is the GCD is not equal to 1, then why this ABC is not a primitive Pythagorean triplet? Okay, so this is the question. How will you let's try this one?
So if U and B have a common factor,
Right.
explain why A and B and C will not be a primitive Pythagorean triplet.
So primitive means the GCD of ABC has to be uh,
1.
1, right?
Yeah, and now they are not 1. Like GCD of U and B, it's
Yes, GCD
something
of U
else.
and B is not 1. So
So they have a common factor. Will not be a primitive Pythagorean triplet.
so here what you can say is, so suppose K is a common factor, right? So suppose this common factor is K, right?
Mm-hmm.
Uh, then I can write is U as K times some U1, right? And V as some K times V1, right?
Okay.
Right. So now if I just put that into the this ABC form of ABC what they are given. So A equals to U square minus V square. So it will be K square U1 square minus V1 square, right?
Mm-hmm.
B is 2UV. So it will be 2K square U1 V1, right?
Yeah.
And C is U square plus V square. U square plus V square, right? Sorry, U1 V1 square, right?
Mm-hmm. Mm-hmm.
So
Yes.
now if I take the GCD of ABC, right? So then it is not equals to 1, right? Because at least K square divides our GCD. Because each of the term has a common factor of K square, right?
Yeah, all of them have k square as a factor.
Right. So here K square is there, here K square is there, right?
Right,
So
right, right. Yes.
right. So this GCD is not equals to 1. So this implies that ABC is not a primitive one, right?
Yes.
Right. So this is fine, right?
Yep. Yeah, good.
Right. So then the part B they're asking is, so find an example of integers where u greater than v greater than 0 uh, that do not have a common factor. Yet the Pythagorean triplet is not primitive. So directly they don't have a common factor, but after computing A, B, and C, still it is not primitive. So their GCD will be greater than 1.
Mm-hmm. Find an example of integers. Mm-hmm. The parent is not primitive. So, okay. So if we want to prove that something is a primitive Pythagorean triplet,
Right.
we can say that A would be equal to S and T, B would be to S squared minus T squared divided by 2, and the other one S squared plus T squared divided by 2. And then the restrictions would be that S greater than T
Right.
greater than 0.
Yes, and S and T are
So,
odd.
and S and T are odd. Okay. In order to say that it's not a Pythagorean triplet, so one of those conditions
Yes,
must be false.
the simple idea is that the GCD will not be 1. So the thing is that is a parameterization given to a primitive Pythagorean triplet. But when we want to prove that it is not primitive, just we have to show that the GCD is not 1. So that is enough. The GCD of three quantities A, B, C, if that is not equal to 1, means it is greater than 1, then it is enough to prove that it is not primitive.
Okay. So how do we generalize two numbers which have a GCD of 1? I mean, what do we
Right.
say?
So, for example, one idea is that if both of them are even, then already they have a common factor, right? So that will not work, right? So what I'm saying is, so both u and v cannot be even, right?
Both U and V cannot be.
Even because I want here that they have they don't have a common factor, right? So I cannot have both of them even, right?
Yes, because A and B should not be even.
No,
And
no,
also
not
S
A
and
and B.
T.
I'm saying that U and V. So I have to find U and V such that they don't have a common factor. Yet, if I consider this Pythagorean triplet, it is not primitive. So U and V cannot be both even, right? Because then they already have a common factor.
Right. They cannot be even. Both cannot be even, right?
Right. So either then only two cases left, that both of them are odd, or one is even and one is odd, right?
Yeah.
Right. So just for a uh, simple trial, we can take suppose u equals to 3 and v equals to 1. So these are the two smallest odd number, right? So that we can take. So where u is greater than 2,
Okay.
right? So let us check what happens to the this Pythagorean thing. So a equals to u square minus v square. So what is that?
8,
8. B equals to 2uv,
6,
6, and c equals to
10.
right. So our Pythagorean triplet is 8, 6, and 10, right? So this is
Yeah.
not primitive, right? Because the GCD is 2.
Yeah, these are not primitive, yes, because yeah, this is
GCD is
2.
2. So this is an example, right? So you just have to find one example that U and V, the GCD between U and V is 1, but once we construct the Pythagorean triplet, the GCD is 2. So it is no longer a primitive one, right?
That's
So
because we are taking a U and B as even, and that's
yes, U and V I am taking the odd numbers 1 and 3. So that is the smallest I can choose, right?
because right now we don't have rules for U and B. There are no rules.
Right, right. There is no restriction. Yes.
Okay, makes sense. Okay.
Okay. So the next thing they are saying is, so make a table of Pythagorean triplet that arises when you substitute all values of u and v from 1 to 10. Okay, that is fine. That we can skip because that will be big. So every value of u and v you have to find the table. So that is fine. Let us try the D part D. Okay. So the question you understand in part C, right? So part C they are saying is, for every value of u and v, I have to find up to 10 what are the Pythagorean triplet. So 1 less than equals to v less than u less than 10, right? So actually one to entries we can check actually. So for example, so suppose this is our v and this is our u. So the first value you can take is 1 and v can take is sorry, you can take is 2 and v is 1, right? So that will give me 3,
Yeah.
4, 5, right? So now the idea is if I take u as 3 and v is 1 that we just computed 8, 6, 10, right?
Yes.
So here I can take v equals to 2. So then what will happen? So u is 3 and v is 2. So we are calculating u square minus v square, 2uv v square plus v square. So this is what we are calculating.
U and B 0.
No, 3 and 2, right?
3 and 2 because U is greater than B.
Yes, yes.
Okay. 3 is going to be now 5,
Right. So 5, 12, 13.
12, 13.
Right. So yes. So next part is when u is 4 and v is 1. Then what will happen?
4 and 1. 16, 15.
Right. 15, 8, 17.
15, 8, 17.
Right. 4 and 2.
12,
Right.
16.
20. So 4 and 3.
4 and 3 would be 7, 24,
25.
25, right?
Right. So maybe one more we can calculate. So so U is 5 and V is 1.
24.
Okay. 24, 10, 26, right?
24, 10, 26, right?
Right. Then 5, 2.
21,
Right.
20,
29.
24,
29.
29. Yeah, 29. Yeah,
Yes.
that's
5,
right.
3.
6.
16.
No, 16. Yeah.
16, 30,
16, 13,
34.
34.
And 5 and 4 it will be 9,
9, 40,
41. So like that it will go
41.
on, right? So let us,
Yeah.
we can do up to this because it is long table, because up to 10 they are saying. So that is fine. So that was part C. And part D, what they're asking is,
Which ones are primitives?
right. So using your table, find some, so they're actually trying to give condition. So find conditions on U and V. Right. That ensure that it is primitive, the triplet is primitive. So any pattern can you see from the table?
Anytime U um, is greater than B in 2.
Yes, so that is always there, right? So U is always greater than V. That is always there. Okay. So this case, it is not primitive, right? This case,
Yeah,
it
it
is
is
not
not.
primitive, right? So let
Yeah.
us highlight which ones are primitive. Then it will make clear. So for example, this is primitive,
3, 4, 5, 5, 12, 13, 7, 24, 25,
right? This is
9,
primitive.
40, 41.
This is also primitive, right? 15, 8.
Yes, 15, 8, 17, 21, 20, 29 as well.
Yes,
9, 40, 41.
right. So these things are primitive. So any pattern.
Yeah, so whenever you subtract B from U,
Yes.
and that's a multiple of 2,
Not exactly, right? So for example, this is 3 and 4, right? So their subtraction is 1, right?
yeah, that's not a multiple of 2.
It is not a multiple of 2, right?
Yeah, but if you subtract 4 minus 2, 3 minus
Okay,
1,
okay. Yes, I
right?
understand. So what you are saying is, so that means that one of them, so one of U and V has to be even and one is odd. They cannot be both odd, right?
Right.
So then only
Yeah.
when you subtract, that is not a multiple of 2, right? So
Yes.
also,
Yes.
also we know that from the first part, that is part A, that U and V cannot have a common factor, right? So
Yeah.
these are the two conditions. So the first condition is U and V have no common factor, and the second condition is one of them is even and one of them is odd. So one of U or V is even. So these are the two conditions. So that will make
I
sure
see.
that this triplet is primitive. So that is our guess. Now party asks us to prove this one. So whether these conditions are correct or not. So how will I prove it? Yes, already I know the first condition that u and v cannot have a common factor. But there's only the second condition you have to prove, that if one of them is even and one is odd, then it is always primitive. That you have to show.
One of your b is given. So I mean we can do the contradiction, right? We can assume that both are even.
No, both are even. That is not possible, right? Because already we know that u and v cannot have a common factor. Yes, so we can assume that both are odd. So the condition is u comma v both even.
Both are odd because we
Yes,
already proved that they are not even.
yes, both even cannot be possible. So next condition, what
Okay,
is left is both odd.
that's the other one. Okay,
So if them are both odd, then
so we can replace u is going to be equal to 2k plus 1, and b is equal to, I don't know, 2k2 plus 1.
okay, let us
K,
use m and n.
okay, m and n. Okay.
Right. So now if I find u square minus v square, it will be
Okay, 4m square.
right.
Oh, okay, 4m square plus 4m plus 1 minus 4n square minus 4n minus 1. Then we simplify that. Square minus,
Right.
yeah.
Then what is b?
B would be 2ub, 2, and
Let us keep it that way. We'll see later. Now u square plus v square.
right. So that would be 4 parentheses.
Right. So yes. So this thing will cancel. So this one and one term will be there, right? So we can take only two common.
Okay, 2n square plus 2n square plus 2m plus 2n plus 1.
Right. So now actually we can see that each of the term has a this has 4 factor, this has 2 as a factor, this has 2 as a factor. So their GCD is at least 2, right? So this is not
Yeah,
primitive.
the GCD of ABC is at least 2, right?
Right. Or we can more say that 2 divides GCD. So it is not a primitive, right? So this implies ABC not primitive.
Okay, so by the contradiction, if it is not, if both are not even and both are
Right.
not odd, they must be one even and one both.
Right.
Okay.
Okay.
I got it. Yeah.
So this is yes. So this is the condition what you showed that this one has to be even and one has to be odd, right? If it is primitive. Okay.
Yep.
Fine.
Yes, I got it.
Okay. So the next one is so second question.
Use the lines to the point 1, 1 to describe all the points in the circle.
Right. So lines through 1, 1 to describe all points on the circle x square plus y square equals to 2, whose coordinate are rational numbers.
But the point 101 is never reached by the circle, right?
Yes. No. 1 is on the circle, right? Because it satisfies the equation, right?
Oh,
That is true.
another kind of circle. Okay, with radius 2. Okay.
No, radius is root over 2 because so the
root over 2, right? Okay,
right.
okay, got it, yeah.
So it's root 2 whole square. So the radius is root over 2. Yes, how will I do that? So what are you doing is, so let us see the thing. So what will be the coordinates? So for example, if it on the x-axis, so y is 0. So this is root 2 comma 0, right?
Right.
This is minus root 2 comma 0. If x is 0, then this is 0 comma root 2, and this is
0
minus root 2. Right.
root 2.
So 1 point will be somewhere here.
Right.
So this will be 1 comma 1. Right. So the same idea. So we take a rational slope, right? So let L be the line. So line passing through 1 comma 1, and slope. So where m is a rational number. Right. Yes. So what is the equation of the line? What will be the equation of the line?
The equation of the line would be y is equal to x, because the slope is 1, right?
Slope is m.
Slope is m, okay. Yeah, y is equal to mx.
Yes, but that has to also pass through 1 comma 1, right? So that condition is there. Now point slope form of a line we have, right?
But the slope at 1 comma 1 is not 1?
No, slope is fixed, right? Slope is you're fixed.
Slope is, sorry?
No, I'm saying that slope is the slope of the line is fixed. That is m, right? So general equation you can take. So y equals to mx plus b.
Okay.
Right.
Yeah. Yes.
Then it should. Then what is b? B you have to find out, right? So it satisfies 1 comma 1, right? It passes through 1 comma 1. So it should satisfy 1 equals to m plus b, right? So b has to be 1 minus m, right? So the equation of the line is, so L, that is y equals to mx minus m plus 1, right?
Yeah.
Fine.
Yeah, so y would be, okay, I see.
So this is the general formula, right?
Right, that's general form.
So general formula given that m is a slope, right? So you have to find this b. So b is the intercept or something you can say. So this is the equation. Is now how will I find? So actually what I am doing is I am drawing a line like this, right? So this is joined. So this has slope m.
Oh, so that slope does not have to pass through 0, 0.
No, that is not there. So anything m I can choose anything. So I can choose this line also, right?
Okay. So it only needs to pass by 1, 1.
Yes,
Okay,
only
I
need
see, I
to
see.
apply pass through 1, 1, and slope is m, right? So now our aim is to find this coordinate. So what will be this coordinate? So this is the question. So how to find?
So yeah, we just need to replace. So if we have two equations,
Right.
the equation of the line and the equation of the circle.
Yes. So we'll
We,
substitute that. So I know the equation of the circle is x square plus y square equals to 2, right?
yeah, we can
So
replace y, for instance,
right. Whole square equals to
equal
2.
to.
Yes. Now expand.
Okay, x square plus n square x square n square plus 1.
Yes. Then minus 2.
Minus 2m square x mx 2mx minus 2m equal
Right.
to.
Right. So if I bring everything to one side and let us collect the terms. So x square, 2 terms are there.
X is
So it is m square plus 1 x square. Then
right. N square.
2 m square minus m x, right? So these two terms.
Okay.
And remaining things are all constant. So m square plus 1 and minus 2m. So this total gives me m minus 1 whole square, right?
N minus 1 square.
Okay.
Okay.
Okay. In fact, actually, we can bring the 2 to this side and also write down that. So it is m square minus 2m minus 1, right? Equals to 0.
Yeah.
Right. So, like the previous one, we already know that. So this is a quadratic equation, right?
So you're saying we already know one root.
Right. So it is a quadratic equation, and also we know that 1 comma 1 is a solution, right?
1,
That
1
is
is a solution, right?
right. So x is a root, right? Sorry, x equals to 1 is a solution, right?
X equal to 1. Yeah.
So then we can actually factor out x minus
X
1, right?
minus 1.
So
Right.
x minus 1 is a factor, right? So then what we can do is the same process. Right. So 2 steps we'll do simultaneously.
X minus 1.
Right. So what should I multiply here? So
X.
that I get x square. M square plus 1 x square.
So you're saying how do you go from n square plus 1 x square to
Right. So suppose here is only 1x, right? What should I multiply here so that I get my first term here as this quantity, right? So if I multiply this into x, right, then I get that expression, right?
yes, you need to have x outside also.
Right. So this terms gives me this term. Now this minus term will give me another term. So that is be minus of m plus 1x, right?
Yeah.
Then how much is left? So we have to adjust this quantity and this quantity, right? So I have taken 1 minus x square and I have taken minus 1, right? But there are 2 minus m square and 2 plus m's, right? So the adjustment will be so plus 2m minus m square and plus 1, right? So if you see these two things together, so this 2m will be this 2m is there, right? So it is minus plus 2m. The minus 1m square and minus 1m square, that is 2m square. And this plus 1 and this minus 1 cancels. So this is my adjusted now, right? And
Okay.
last term I have 2m plus 1, sorry, minus 1. So the next term is, so here actually what you can see is that these two coefficients are nothing but just the signs are opposite.
Right.
Right. So if I take minus of m square minus 2m minus 1 times x minus 1, then we get that x expression, right?
I see.
Right. So from here what you can do is, so x minus 1 is a factor and remaining I have so this part gives me the second root. So x equals to
N squared plus 1.
right. So the rational point on the circle, right, will be so this will be nothing but x comma y. Okay, so we have to find the y coordinate also. The x is this one, right? So what will be the y coordinate? Tell me.
I mean, we will need to replace.
Yes. So equation is, we know y equals to mx minus m plus 1, right?
Oh, yeah, we can replace the test. It's easier.
Right.
Mx minus.
Right. Tell me what will happen. So it will be m
N
into,
cube.
right, m cube minus 2m
2m
square minus
square. N squared plus 1 minus n plus 1.
yes. So if I simplify,
Okay, you will multiply that. Okay, that would be minus n cube, so it's gone. Minus n cube minus n minus n squared. Yeah. Okay. So we, okay, so minus n squared minus 2n m plus 1. M squared plus 1.
yes. So this is our y. So the solution is this thing. Right.
Yeah.
Right. So this is the part A what they are asking. So they asked to find right. So so this is this point, right? What you found out.
Yeah.
Okay. So what is the next part?
But wait, how do we ensure that these are rational numbers?
Yes, these are rational numbers because m is a rational number, right?
M is
M,
a rational number.
right? M is a rational number, and any rational combination of a rational number is again a rational number, right?
So we assume that the slope is already a rational number.
Yes, that is already given in the question, right? So they are saying, right? So whose so we are coordinates are rational numbers. Yes. So we are assuming that m is a rational number. Yes. The slope m is a rational number. That is we are assuming.
Okay. I see. Yeah.
Right. So part 3, what they're asking is, part B. Part B, what they're asking is what goes wrong if we try to apply the same procedure. If the circle equation is slightly changed, that is x square plus y square is 3 now, then what will happen?
So you still have the same root x minus 1,
But see, one observation what we had is, so the first one when we did is, yes. So this first one when you did is, we actually the main point is we start with a rational solution, right? So this minus 1 comma 0, this is a rational solution to the equation x square plus y square equals to 1, right?
Right.
And then we took a line that passes through minus 1 comma 0 and rational slope, and then we found the solution to all the rational points on the circle, right? So here also, if you remember, so here also we actually found 1.1 comma 1 that is on the circle, that is a rational solution to the circle, and then we found all the remaining by just passing line with a rational slope, right? But the question is, what happens if we take x square plus y square equals to 3? So
But
so does it
again,
has
we have 1, 1 as a solution.
No, 1 comma 1 will not work, right? Because
It's not
1
work.
yes. So
Okay, I see. So we need to start with rational.
right. So we have to first figure out that whether a rational solution exists to the circle or not.
So that solution is not a Pythagorean triple.
Yes. So actually, yes. So actually the circle does not have any points with rational coordinates.
That circle, sorry, does not have.
So this circle, so does not have any point with rational coordinate.
Any
So we
point?
cannot actually begin the solution itself. So it does not have any solution. So you cannot find any solution with rational coordinates. So once we can start, then only we can find all the other things, right?
Because you're saying there is no rational number
Right.
that elevated to the square plus another rational number to the square doesn't give 3. Does not exist that.
Right.
Okay.
But how will you? But how to show that? That is also the thing, right? So the argument is, so suppose you have it has a rational solution, right? So then x equals to some a by b, and y equals to some c by d, right? Then so since their sum is an integer, so the denominator has to be same, right?
The sum is an integer.
So sum of two rational square is integer, so the denominator must be same.
But you mean the square of those, right? The square of x and the square of y.
Yes, more or less we can simplify. So the thing is a square by b square plus c square by d square equals to 3, right? So if we simplify, a square d square plus c square b square equals to 3b square d square, right?
Right.
So eventually we are having some solution of u square plus v square equals to 3w square, right? So some sort of this thing, right? So from here, actually, you have to arrive at a contradiction that this type of thing cannot exist.
Because so doesn't mean. But where is the contradiction exactly?
Yes, tell. Yes, tell me.
Okay.
So the thing is here that so from this thing, what we have is 3 divides each of the thing, right? So 3 divides the sum. So from this thing, 3 divides AD square plus BC square. So this implies 3 must divide AD square, and so that actually we can show. Okay.
Okay.
So from here, actually it implies that 3 also divides BD.
3 also divides BD.
Yes, because
Why?
it is a square quantity, right? So if 3 divides this quantity, means 9 divides this them, because everything appears in pair, right?
Sorry, repeat that.
Yes, what I'm saying is 3 divides any square quantity, right? Because it is a square, perfect square. So 9 should also divide that, right? Because any number, it cannot have only single power. So the powers are occur in even.
Okay. So only the last part it's just not very clear. Like, how
Yes, yes.
come 3 divides B and D?
Yes, I understand. So the thing is, yes, it will take some time. So we'll maybe to do in the next session. Okay. So try to figure it out. Otherwise, we'll do it in the next session. Okay.
Okay, sounds good. Thank you.
Okay. Bye then.
Bye bye.